All right, let's solve another example. This time it is question 97. So in question 97, we are given a series circuit with a battery of 18 volt with three resistors, R1 4 ohm, R2 1 ohm, and R3 4 ohm. We are asked to find different values. So let's read the question. Part A, we need to find the equivalent resistance of the circuit. Part B, find the current through each resistor. Part C, find the potential drop across each resistor. Part D, find the power dissipated by each resistor. Part E, find the power supplied by the battery. So remember, the equivalent resistance would be if we were to take these three resistors, combine them together, and recreate a circuit with a power supply and one resistor. What would be the value of that resistor? Well, in this case, it's a series circuit. To find the equivalent resistor, we need to add them up. We need to add the resistor up. So first, I drawn that Ohm's law table. It is a useful tool. It helps us often highlight what is the next step we need to do in order to get the information we need. So in this case, we are given the resistance. So we got R1 4 ohm, R2 1 ohm, R3 4 ohm. Now, it's a series circuit. This one is really simple. We simply add up the resistor. Well, we get an equivalent resistance of 9 ohm. Now, one thing you need to think about when you're talking about the equivalent resistor. The equivalent resistor, the voltage drop across the equivalent resistor is always the voltage of the battery itself. If you think about it, you replace these three battery with these three resistor with one resistor, and the complete voltage is applied on that resistor. So that means we got 18 volt on the equivalent resistance. Well, if we, by Ohm's law, we found the voltage, we found the equivalent resistor, that means we can find the current. It's 2 ampere. Now, here's the thing. This is the current flowing through the battery here, and note the plus is pointing downward, so the charge will be going that way. Well, there's only one path for the charge to follow. They will leave the battery, go through the third resistor, second resistor, first resistor, go back into the battery and get another bump of energy, boost of energy. And what that means is all the charge going through the power supply will go through R3, R2, and R1. What that means is we just found the current through each resistor. It's 2. It's the same. It's a series circuit. All right? Well, now, if we got the current through each resistor, it's easy to find the voltage drop. We just multiply these two. So we got 8 volt on R1, 2 volt on R2, and we got 8 volt on R3. All right, we are basically almost done. We just need to find the power on each resistor in the complete circuit. All right, well, power is voltage multiplied by the current. So we multiply these two. We got 16 watt over here. 2 multiplied by 2, we got 4 watt over here. 2 multiplied by 8, we got 16 watt. 2 multiplied by 18, we got 36. Now, note an important aspect here. Energy is conserved. So, the energy consumed by each resistor has to equal the energy provided by the power supply. Now, to know what is the energy provided by the power supply, you need to look at the voltage provided by the power supply and what is the current going through the power supply. So 36 is equal to 16 plus 4 plus 16. Okay, they are both equal to 36 in this case. And it has to match by the conservation of energy law. All right? So that's it for question 97. In the next question, we're going to be solving a problem related to parallel circuit, and then we will move on to mixed circuit. All right? So just as a reminder, you could probably avoid building an Ohm's law table, but it's a very convenient way, and it often will help you when you get stuck and you don't know what to do next. It becomes way more obvious what is the next step when you're building these tables, okay? Anyway, in a test, you need to write down each step of the calculation. So having an Ohm's law table, I think is a convenient way to do both at the same time. All right, so see you in the next video.